Hi everyone, welcome to the channel. Now we'll learn about polyalphabetic ciphers and specifically about beginner cipher in this video. The polyalphabetic substitution cipher is nothing but a technique in which if we apply or use different monoalphabetic substitutions as we proceed through the plain text, that is called polyalphabetic cipher. In a monoalphabetic cipher, for every plain text alphabet, there is a unique cipher text alphabet. Each plain text alphabet is mapped to a unique cipher text alphabet. But let's say you have a message like A, B, C, A. In a polyalphabetic cipher, the first A, if it is mapped to M, the last A need not be mapped also to the same M. So you need not have same ciphertext alphabet for every unique plain text alphabet. So different monoalphabetic substitutions will be used as we proceed through the letters of the plain text, and that is called as a polyalphabetic cipher. So all of the polyalphabetic cipher techniques will have two features in common. One is they will make use of monoalphabetic substitution rules. They will make use of a set of monoalphabetic substitution rules will be employed. And which monoalphabetic substitution rule is going to be chosen for a particular transformation or encryption is dependent on the key. The key will determine that. So specifically, we are going to learn about Vigenere cipher, which is one of the best and simple polyalphabetic substitution algorithm. So in Vigenere cipher, what will be done is it consists of a set of related monoalphabetic substitution rules in the form of 26 CIHER ciphers. 26 CIHER ciphers are used to implement the monoalphabetic substitution rules. So each of these 26 CIHER ciphers will have shifts from 0 to 25. So the first CIHER cipher will have a shift of 0. The second CIHER cipher will have a shift of 1. The third CIHER cipher will have a shift of 2 and so on. So recall that CIHER cipher means each letter or alphabet in the plain text will be replaced by another letter standing k places further down the alphabet, where k is your shift value. If the k value is 3, then each letter of the plain text will be replaced by the letter standing 3 places down the alphabet. So this Vigenere cipher makes use of a table called as Vigenere Table. This Vigenere Table is a 26 into 26 table which has A to Z in the row header as well as in the column header. The letters from A to Z in the column header represents the letters of the plain text. The letters A to Z in the row header represents the letters of the key. Then how this Vigenere table will be filled up is, it will be the first row of this table has all the 26 English letters from A to Z. You can see that the first row is filled up with letters from A to Z. And then starting from the second row, each row has the letters shifted left by one position in a cyclic way. Cyclic way means you can see that in the second row, B occupies the first position, C occupies the second position, D occupies the third position, and so A occupies the last position in the second row because the elements are filled up in a cyclic way. So with this, like this, we fill up all the elements of the Vigenere table. You can see that the first row is a CIHER cipher with a shift of 0. The second row is a CIHER cipher with a shift of 1. And the third row is a CIHER cipher with a shift of 2 and so on. So this is how the Vigenere table is filled up. Now we have the Vigenere table. How is the encryption process done in this Vigenere cipher is, Vigenere cipher makes use of a keyword, and the requirement is the keyword has to be as long as the message. What will happen, let's say if my message contains 25 characters and if my keyword is just 10 characters in length, then in order to pad the remaining characters in the keyword, the key is itself repeated. Okay, so that its total length becomes equal to that of the plain text. Key itself is repeated. Say for example, if the plain text is Anna University and if the key is Houghton, Houghton, then in order to fill up the remaining letters of in order to make the total length of the key equal to the length of the plain text, the remaining letters of the key is filled up by repeating the key itself. You can see that again H and T is filled up. So this is the first step in Vigenere cipher encryption. So you have to pad the key in such a way that the length of the key is equal to the length of the plain text. Next, to encrypt and convert the plain text to ciphertext, what we will be doing is, we will be picking up a letter in the plain text, which will appear in the column header, and we will pick up the corresponding letter in the keyword, and we will find the entry at the row column intersection. So this will be the letter in the ciphertext. Say for example, if your plain text is A and if your key is here, your key is H. So for the plain text A and for the key H, you have to look up in the Vigenere table. You have the plain text A in the column header and you have the key H in the row header. At the intersection of the particular row header and column header, you have the letter H. This is the corresponding ciphertext letter for the plain text A and for the key H. Similarly, the next one is, you have the plain text letter N and you have the key O. And then you have the plain text letter N and you have the key U. So you look up for the plain text letter N in the column header and you will look up for the key O in the row header. You are getting the letter B at the row header and column header intersection. Now B is the corresponding ciphertext. Similarly, at the plain text at the column header N and at the row header U, at the intersection of the column header and row header, you have the letter H. So H will be the corresponding ciphertext for the plain text letter N and for the key U. So it proceeds like this. Say next you have the letter A in the plain text and the letter G in the key. So for the plain text letter A in the column header and the letter G in the row header, the corresponding element at the intersection is G. So G is the corresponding ciphertext letter. So in this way, it takes each and every letter in the plain text and its corresponding keyword in the key, and it will find the letter in the intersection from the Vigenere table and then fill up the letters in the ciphertext. This is how the ciphertext is calculated, and then this process will get repeated until all the letters of the plain text gets processed. So here, this is the corresponding ciphertext for the plain text Anna University. So next, if you want to do the decryption, what you will do is, you will pick the corresponding letter in the keyword and the letter in the ciphertext and use the keyword letter to find the corresponding row, and you will use the letter heading of the column that will give you the needed plain text letter. Say for the key H and for the ciphertext H, the corresponding value of plain text in the column is A. So the corresponding plain text for the ciphertext H and for the key H is A. So this is how decryption is being done. So decryption is simply done by looking up the particular key and the corresponding ciphertext value in the corresponding row and then looking up the column header straight to it. So same way, so if your ciphertext is B and if your key is O, look up the key O and the ciphertext is B and the corresponding plain text letter in the column header is N. So the corresponding plain text letter for the ciphertext B is N. So this is how decryption process is being done. So if you examine the strength of the Vigenere cipher is obviously able to obscure much of the information, hide much of the information from the plain text in the ciphertext. So because we are making use of multiple ciphertext letters for each plain text letter, so much of the information is hidden, but still some amount of information from the plain text is still visible in the ciphertext. So say for example, if the cryptanalyst suspects that a Vigenere cipher would have been used for encryption, then how he would proceed is trying to find out the length of the key which has been used for encryption. So one useful insight is, if two identical sequences of plain text appear at a distance which is an integer multiple of the keyword length, then they will generate identical ciphertext sequences. Say for example, consider this example. So here you have in the plain text, you have the letters RED. The sequence RED appears at a distance of 9 again. Okay, so thus that sequence RED in the plain text produces the same ciphertext sequence VTW. Okay, this sequence RED also produces ciphertext sequence VTW, and this sequence RED also produces the same ciphertext sequence VTW. So they will generate identical ciphertext sequences because the length of the key is 9 here. So from this, so two instances of the sequence read are separated by 9 character positions. So in both the cases, R is encrypted using the key letter E is encrypted using P, and D is encrypted using the key letter T. So that's why they are producing the same ciphertext sequence VTW. So the cryptanalyst will predict that the key is either 3 letters in length or 9 letters in length. So in general, if the keyword length is n, then the ciphertext will consist of n monoalphabetic substitution ciphers. So thus, the cryptanalyst can use the known frequency characteristics of the plain text to attack each of the monoalphabetic ciphers separately. So in order to avoid this type of repeating nature of the keyword and an attack on the attack by the cryptanalyst, this periodic nature of the keyword can be eliminated. This was eliminated by Vigenere by using a non-repeating keyword, but still it is as long as the message itself. And that system is called as auto key system. So in this auto key system, a keyword is concatenated with the plain text itself to provide a running key. Say, for example, here you can see that the keyword is deceptive, and then to fill up the remaining letters of the keyword, the plain text itself is attached to, concatenated with it. You can see we are discovered. SAV is being attached to the letters of the keyword. So this type of system is called as auto key system. But even this scheme is vulnerable to cryptanalysis because the key and the plain text, they share the same frequency distribution of letters. So the attacker or the cryptanalyst may try to apply a statistical techniques. For example, E occurs more frequently in English language than T. So these type of regularities may be exploited by the attacker to achieve successful cryptanalysis. So that is all about Vigenere cipher. Thank you.